Okay, hello all. So now we will try to explain example 2 of triangles. What is this example 2 state? ABC is a trapezium. So you know if ABC, if it is a trapezium, then there are one pair of parallel sides. AB is parallel to DC. That is also given. E and F intersects side AB and BC respectively, such that E and F intersects AB and BC, then EF is parallel to AB. If EF is parallel to AB, then it's also parallel to DC. So this is not there in the textbook, part of it is gone, so you can write it yourself. EF is parallel to AB, AB is again parallel to DC. So what we need to prove? We need to show that AE on ED is equal to BF on FC. This is what we need to prove. So this is a basic proportionality theorem. This looks like basic proportionality theorem question, but the diagram we don't see any triangle. Basic proportionality theorem applies to triangles, but here we don't see any triangles. We'll come to that. First let's write what is given. Given is AB is parallel to DC. AB is parallel to DC. EF is parallel to AB. EF is parallel to AB. This is already given from the statement. So to bring basic proportionality theorem here, we need to construct a line between, because what do we need? We need AE over ED. AE over ED. So we need this side to be there. So we will construct a line from A to C to make a triangle ADC. Now we can apply basic proportionality theorem, and the point where it meets line EF, we can call this as D. Now if you consider triangle ADC, consider this first of the triangle ADC, triangle ADC. From triangle ADC we know EG is parallel to DC. How? Because EF is already parallel to DC, which is already known, because if EF is parallel to AB, it is also parallel to DC. If EF is parallel to DC, then part of this line EG is also parallel to DC. So we will write the basic proportionality theorem for this. So what does that lead to? AE over ED is equal to AG over GC. Sorry, AG over GC from basic proportionality theorem. What does basic proportionality theorem tells? If there is a line parallel to its sides, the other two sides, if the line intersecting the other two sides is parallel to its base, then the proportion of other two sides are equal. That means AE over ED is equal to AG over GC. We'll call this as equation 1. Now we will consider the other triangle, triangle ACB. In triangle ACB, again GF is parallel to AB, because EF is parallel to AB, which is already given in the statement. Now if we have to apply basic proportionality theorem, what do we get? We get CG over AG is equal to CF over BF. Why CG over AG is BF, CF over BF? Because we are considering this triangle. In this triangle, if you have to apply basic proportionality theorem, we have GF is parallel to AB. So the other two sides which the line is intersecting is AC and BC. Therefore, the ratio of these two sides is CG over AG is equal to CF over BF. This is again basic proportionality theorem. We call this as 2. Now what we need to prove? We need to prove AE over ED is equal to BF over CF. AE over ED we already got in statement 1. And what do we have here? We have CF over BF. We don't have BF over CF. We will take reciprocal of this statement. We will take reciprocal of equation 2. What do we get? AG over CG is equal to BF over CF. After taking reciprocal of this equation, we get this equation, AG over CG is equal to BF over CF. So if you see equation 1 and equation 3, you have AE over ED is equal to AG over CG. AG over CG is BF over CF. Therefore, from equation 1 and equation 3, AE over ED is equal to AG over GC, that is equal to BF over CF. Finally, this is again equal to AE over ED is equal to BF over CF. That is what we had to prove. So hence prove.